What is up? Serpent here. In this short video, I'm going to go over a feature of the Serpent.AI framework, the gameplay recording, quite the feature. I'm going to go and show you how to work with this from pretty much zero. So let's just assume you have the framework installed, and we'll just go from there. We'll just go from there, from zero to recorded gameplay. All right, so I'm in my Linux environment right now, but as anything Serpent.AI, you could do the exact same thing with Windows and Mac OS, so no worries there. So the first thing you want to do with anything Serpent.AI, when you're just like getting started, is pick a game, right? So that goes without saying. So we're gonna pick a game, and the game I'm gonna pick for this little demonstration is gonna be Super Hexagon, right? So I think most people would be familiar with this game. It's already installed. It's on my Steam on Linux. It's already installed and ready to go. So without further ado, let's see what I would do with Serpent.AI to get that up and running. So the goal of this video, once again, I want to demonstrate the gameplay recording feature of the framework. And we're going to do this inside of Super Hexagon. So nothing's prepared in advance except that I have a working install of Serpent.AI, right? So I'm going to go and say we need game support first, right? So everything in Serpent.AI is well, the main components are plugin based. So what we'd have to do is create a plugin for the game, right? So I'll go and say Serpent generate game. There's a bunch of handy generators, code generators. So this is going to create like a bunch of like directories and code files for you, kind of like a nice little starter skeleton for your plugin. So we're going to run that right there. All right, so it's going to say, it's going to give me a little prompt. It's going to say, what's the name of the game? So we want something that's titleized, no spaces. So we're going to go and say Super Hexagon like this. How's the game launched? So Serpent.AI supports a variety of, let's just say like platforms or ways of launching the game. But in this case, it's pretty obvious that it's going to be Steam. So I'm going to say Steam. And it's just going to go through the installation, give you a bunch of output, mostly plugin installation stuff. And that is it. I'm going to clear the terminal here. We're going to go over to the code editor. And if you look on the left-hand side here, you'll see that it did generate Serpent Super Hexagon plugin. So this entire thing that you see here, well, let's never mind the PyCache, but everything else, like the plugin.py and everything in files here, that was all generated by that Serpent command. I'm going to focus on Serpent Super Hexagon game.py. I'm going to open this, clear out a bit of the white space. The white space is kind of due because this is generated dynamically. You know, like based on your platform and everything like that. So it's not perfectly clear, but it gives you a nice starter plugin, a nice skeleton to work with. So how do we get Serpent.AI to recognize our Super Hexagon in a way that we're able to work with it, right? So there's two things with Steam games. I would say with any game you would need a window name, and Steam games in particular you would need the app ID, the Steam app ID. So let's start with the Steam app ID. So if I go to my Steam, right here. The easiest way, like there's many ways of getting an app ID, but one super easy one that I know of is if you go to the store page on Steam and you just right click and you copy page URL, right, and you go back to your code here. Let's just fill in the entire URL and see this 221.640. That's part of the URL. That's the Steam app ID. So we can use this to get started. All right, so we're going to use this here. And the window name on most platforms, it is safe to use whatever window name the game window has. But sometimes on specific platforms like Mac OS, that's not going to work. You need something more akin to the process name. There is, however, a little utility that comes with the framework, and I encourage people to use it, even though in some cases it's really obvious what the window name is. So what I'll do here is I'll manually launch Super Hexagon for a second. Totally muted. You probably won't hear anything, so that's probably better that way. So here's my Super Hexagon window, right? It's running on Linux. and you'll see that the window title is super hexagon. But let's say we don't really believe this, and we need to be sure that we're using the right window name. There is a command that is called serpent window underscore name, and if you run that, it's going to tell you open the game manually, press enter, and then focus the game window. So I'm going to press enter. I'm going to focus the game window. Wait a couple of seconds. And it tells me, hey, I detected your game window, and here's what you need to put in your game plugin, super hexagon like this. So like I said, in this case, it's really obvious because it's the same thing as what's in the title bar. But on some other platforms, sometimes it's not as obvious as this. All right. So now you put this in for your window name. Everything else you can kind of leave as is, and already we should be able to launch super hexagon and control its game window from the Serpent framework. So I'm going to say Serpent launch super hexagon like this, and just give it a second. You'll see that Steam launches the game, and then takes control of the window and places it at the top left. So that's a good sign that the Serpent.AI framework is able to work with your game and is kind of good to go, right? And there's a bit of output here. It's detected the properties of the window, so stuff like the width, height, the offset. Once it's positioned it, that's going to be kind of crucial for frame capturing. But that's all you need to do, like on the launch side. So you don't close the game. I would say you leave it open at this point. I can clear my terminal. And you'll notice that the launch command also returns. It doesn't like keep a process up or anything. That will return, so you're able to run some further commands from here. Speaking of further commands, in order to record, because we're still going for gameplay recording here, what you will want, even though we won't necessarily do a lot in it, if anything, is a valid game agent. Right, so we're using game agents to scope the recording, essentially because it's possible to register reward functions that are game agent or game specific, and that could be something that's a little more advanced. But if you're doing reinforcement learning stuff, you could technically register a reward function in your game agent, and then when you record, it will also pass the sequence of frames through your reward functions to generate a score. So that's a possibility. This is kind of why you need to also have a game agent there. So we're gonna generate one for this. We're gonna say serpent generate generato. We're gonna serpent generate a game underscore agent, and kind of like the similar setup here. Same thing. So I can enter exactly the same name. I recommend people do that normally. Just because it makes it simpler. You're kind of free to do what you want, but if you use the same exact name that you use in your game plugin, it's just going to make it easier to find your stuff in your working directory. So I'm going to say this. I'm just going to wait. It's going to generate another plugin, totally different. This time it's a game agent. I go back to my like code editor here, and you'll see that there's also a super hexagon game agent plugin. Right. So if I go inside right here, game agent, and see it's just a really small skeleton, but there's a bunch of supporting files once again. The important part is not necessarily what's in your skeleton here, but rather that it's properly set up and extends the game agent class, and it can also be used as a target, as you'll see, right? So I can record at this point, but there's one additional thing I would like to do. Recording is a data intensive operation, right? So you'll be playing the game, you'll be generating mouse and keyboard events, and associating that with frame sequences. So the one thing I would say is, in order for our file size to be reasonable and your memory usage not to be too crazy, it will be beneficial, especially when you consider, like how you use, like you prepare these machine learning data sets. If you're using like neural networks and in convolutional neural networks, you probably don't need to work with, actually, not that you don't need, you probably don't want to work with full resolution frames at all. So what I'll do, just to keep the file size under control and just, like be friendly towards our RAM a bit, I'm going to set up something called a frame transformation pipeline with our, that needs to happen in the game, not the game agent. So let's go in the game here. Right, and on top of like what's already here, I'm gonna add self.frame transformation pipeline string. All right, so how do you define a pipeline, a transformation pipeline for your frames? You can just use a little string, you know, like little DSL or piped commands from a string. So in this case, let's say I want my frames to be resized. Let's try to use something that's, you know, that's pretty decent here. Let's say I want to resize to 200 by 200, and then I'm gonna pipe this to, well, I could choose to use grayscale. I could choose to use some other commands, but I think we'll keep it full color for this demo. Why not? It's still gonna be a little more visual. So let's just resize to 200 by 200. I think it's a no, I don't even remember. If you're wondering, like this is definitely like my style of video. I'm mostly a live streamer, so I'm definitely just gonna do a one take, and if I make a mistake, I'll just correct it. So let's go. I think this is fine, but it could also be a capital X. I don't remember exactly, but we'll just use this and make sure that they end up being perhaps like represented as floats like this. All right, so that's fine. You can chain a bunch of commands. You would have to refer to the Serpent.AI documentation to kind of learn more about the frame transformation pipeline. But this is probably going to be enough. So it's going to end up, whatever we're capturing, we're also going to put through this pipeline. And whatever we kind of query from our active frame buffer, it's going to be possible to get stuff that is following this pipeline here. And that's going to make it easier for us when we record, right? It's going to be a little easier in terms of file size and RAM usage. So let's go, without further ado, I think this is a valid pipeline. We're about to find out if it's the lowercase x or the capital X. Let's clear our terminal just to make this a little easier. And we're going to go ahead and that's it. We can just record our gameplay. I'm going to say Serpent record super hexagon with. Right, so the commands, like there's been an effort that's been made with the Serpent command so that they relatively make sense. So in this case, like it's literally like, hey Serpent, record super hexagon with the Serpent super hexagon game agent. Right, so that's what we're passing along. Super hexagon game agent. All right, like this. Now we're gonna start this here. We're gonna have to give it a second to initialize the framework. But it's going to tell us when it's ready to go. When it's ready to go. Now, do not expect like fantastic gameplay here. I am not a great super hexagon player, especially not under pressure. All right, so it tells me start playing the game, focus out when you are done or want to save the collected data to that point, because it is possible to resume, right? So you can just, like, if you have an existing file, you can just start another recording session and append to that data. I'm not going to get into that, but it's a possibility. That's why the message kind of goes that way. So I'm moving my mouse around, start game. So I'm going to use, let's say I use the mouse here a bit. I'm going to press enter. And it's not going to really give you any output. Maybe in the future I can add some sort of like debug mode, so if you want to see your key presses. And there we go. I'm not even gonna focus on whatever's on the right. I mean, super hexagon is definitely something you need to focus on. But I don't need to. That's the whole point. I can just play as I normally play. Now the cursor might be annoying. But I can just play the game, right? There's nothing else that's required of you. You just play as you normally play. And nothing special there. All right, so I'm going to play for, I'm not going to spend too much time playing this thing, but let's say we want to get a legit session underway. All right, something like this. I'm going to go until I die. How about that? And once I die, we'll just call it. Oh, well, there you go. All right. So when you're done, let's say this is my play session. Of course, you're going to want, in real life, you're probably going to want to go for a lot longer if you're trying to collect data that you can use for like machine learning models. But let's say I'm done, right? So I would just focus out and click my terminal window here, and it's going to start telling me that it's recording the observations to an HDF5, an H5 here, and it's actually really quick. It's already done, and I can just say like I'm done. So I'm going to Control C out. We can leave super hexagon here. Doesn't really matter. I'm going to open my stuff in my file system. I'm going to navigate to my Serpent.AI directory, my working directory. And in datasets, you now have this input recording.h5, and this is where it all went. And this file, right now, I didn't play for very long, but sits at around 32 megabytes. Right, so it's really not that bad considering all that we probably have in there. So the next step, I mean, that's it. That's literally it. You can record, like, as long as you play with the mouse and keyboard, you can do this, whatever I just did, with whatever game you prefer. It's going to work exactly the same way. And you're going to end up with this input recording.h5 in your datasets folder of your Serpent.AI installation. So how about we start looking at what's in there? I think that's the other part that's quite relevant before we call it a video. So I have a notebook that is actually in the repository for Serpent.AI, right? So it doesn't get installed along with the framework, but if you do go to on GitHub, you go to the repo, there is a notebooks at the top level of the repository, and there it is, reading recorded inputs. So it's a little notebook that kind of gets you started. It looks exactly like this. It has a bit of markdown that explains some concepts and then relevant snippets of code to kind of start like reading this. In the future, I do envision having some sort of like modular class to handle this thing, right? To probably just like make it accessible as Python structures. But for now, we're kind of content with just having the HDF5, right? So I'm gonna run the notebook literally. So getting a few modules in there and establishing my file path. I don't know if I'm running this from my Serpent. Let me just try to go back to the home there, the home directory. Let's grab this for a second. I want to make sure I'm running it from my Serpent projects and not my. I'm not. All right. So I will just need to tweak this. But essentially, you need to point to this. You can use like anything you want. You can use like, if you like to use like path join, you can use that. You just need to point to the file. So I kind of know where it is from here in my case. So it's in here in Serpent.AI. Datasets input recording. All right, cool. Then it goes over the file structure. So for every frame that gets captured in the framework, right, we're going to grab a frame buffer around that frame. So not just that frame, but also some frames that came before and one frame that came after. So not only do we have the exact frame where the input happened, we'll also have the context of what happened before and something that happened after, which is really, really useful. I mean, we're trying to package as much information, useful information there. You might not need to use it like this, but chances are you'll have enough information to do whatever type of machine learning, reinforcement learning that you were trying to do with this sort of structure here. So every frame that gets captured by the game agent, we grab the buffer that I was talking about, which is totally possible, and it's going to generate an entry. There's going to be a timestamp for that frame. It's going to generate like 5 data sets in the HDF5 for that single time frame. All right. So if you want to inspect the actual keys of my current file, I could just run this cell here, and it's going to kind of like output all the keys along with the timestamps. So you can kind of see all the keys that are there. So this is a single frame along with its, its context. There's a frame sequence in frames. Then you have keyboard inputs. Keyboard inputs is what happened at exactly that point in time. So most times this is probably going to be empty. But if something happened to be captured at that point in time for that specific frame, it will be in there. Now there's also keyboard inputs active. That's another one. This one is a collection of the stuff that was already pressed and is still pressed from previous frames. You have your mouse inputs, so anything that's happened with the mouse during that frame, and then reward, totally optional, but it is possible to register a reward function in your game agent. And what's going to happen is the currently registered game agent reward function, every frame sequence will get passed through that reward function. So you'll have your scores, your reward scores for every frame, essentially. Now that reward function is up to you. All the reward function gets is the frame sequence. So you are free to implement your reward system the way you want. And that's it, right? So that's going to leave me like a bunch of keys like this, a lot of keys, but that's kind of like the name of the game with this here. So all of these are keys inside of our data sets inside of our HDF5 file. Now, if you want to get a little more, like personal / visual here, well, we can start like working with some pieces of data. So let me just kind of go middle of the road here and try to grab one that says frames, right? So I'll just pick a timestamp that says frames. I'll scroll down a bit and replace my prefix here, right, with that timestamp. And if I just run this cell, you should see the context. You should see the frame context around that point in time for that specific entry, right? So look at that. We kept it color, right? We kept it in color. I didn't change it to grayscale or anything. So let's say we assume that color is relevant in our game. Probably not the case in Super Hexagon, but hey, you never know. And there you go. So how does that one read? Well, the third one here, it's always like this can be a customized. I didn't really mention that you can customize the size of your frame sequence, and I'll show you right now. I think it's worth showing. Just give me a second. Let's do. Yeah, now let's go to the terminal again. When you do that recording session, right? Let's bring this over here for a second. I can append some extra information, right? I can say how long I want that frame sequence to be. So by default, it is a 4 long sequence, and they're all spaced out by 4 frames. So, I mean, you'd have to understand a few things about the Serpent.AI framework here to know what that means, but essentially there is a frame, when you do anything with your game, there is a frame grabber process. It's a separate process that runs and captures at a locked 30 FPS, right? And that's kind of like an assumption. For most machines, for most hardware, it's going to be able to keep up that 30 FPS, locked 30 FPS capture. And it essentially just like keeps that in a buffer in memory. So it's kind of like a stack that has a specific length, and just like the latest frame always gets put on top of the stack. And it's at 30 FPS, right? So I can say, instead of 4 frames, what if I wanted 5? Well, I would just say 5 here. And this is how far apart the frames are spaced. So you can also control the spacing between those frames. So I could leave it at 4 like that, right? So if we go back here, in this case, I was running at the default of 4:4. So these are 4 frames, spread apart by 4 frames. And the rule of thumb with the recording is that the one before last is always going to be the one that's used for the timing of the action. So if there's any keyboard or mouse actions, they're pretty much lined up. Not exactly always, but this is the closest that they can be lined up with. It's going to be this frame right here. So the other ones are the stuff that came before. So if you want some sort of context to infer, like movement or stuff like that, well, you're going to have a few frames like that to do that. And there's also the frame that followed the action, and that's useful for a lot of like reward, reward functions for reinforcement learning systems. You kind of like to know like you have your action and then whatever came after, and it kind of sets you up for that. So if you want to look at the one before last, like where the action would have actually happened, you can do that with the other cell. All right, so you kind of see it. A little more detail. Now you'll remember that our frame transformation pipeline was 200 by 200. So if you kind of look at this plot here, you'll notice it's around that, and it's also color. It's also distorted the aspect ratio a little bit, but that's part of the game here. I like to work with square images when I do my convolutional neural nets. So you get something like this, right? And then you can look at the inputs, right? So the snippet will set you up to kind of look at every single point in time in your HDF5 file where you had an actual keyboard input for that frame. You can switch it to, as the comment says here, you can switch it to the other types if you want to see the mouse input or the active stuff. But if I were to run this, you'll see like, hey, like this is what was done for how long. You could print some extra information if you want to know the timing and everything, but just know that you can kind of extract that information. So all of my key presses, you'll see in a pretty standard format, are there along with the duration of the key press. So I press left for 0.36597 here, right? And so on and so forth. Now, if I want to see the mouse, same thing. I could just copy this here. If I want to see the mouse inputs, boop, right? So now you have like move and maybe some clicks. See, click left. There you go. So that's it. That's it. So you can do this for any game. All right, you can do this for any game. It's going to record your keyboard inputs, your mouse inputs, give you the context of the frames, the key presses, and the active keys. And then you can use that to build your own machine learning models from that. So there's two goals. I guess like there's one that's really, really simple and probably just like a more a fun goal would be to just like use all of this collected information to build some sort of like static model, right? Supervised learning model. So you could use this information to just say like, hey, this is a bunch of data. When your context looks like this, you do this, right? And then the next step over that, which I think is really, really more interesting. I won't go too much into it, but you can use this, as long as you register your reward functions, you could use this to bootstrap some reinforcement learning experiments, right? So typically neural networks, they get initialized with random weights. So this is kind of like the equivalent. I'll try to word it in a way that hopefully makes sense a bit. So you know all the models or the weights that emerge out of the ImageNet competition, right? So normally you'll never use these algorithms with the weights and just like this, right? Usually you'll use that with some sort of transfer learning. So you'll use the initial weights of the winner of the ImageNet competition, but then you'll fit it to your own data set. So we're going to do kind of like the equivalent here. That's the goal of this feature. If you're doing reinforcement learning stuff, the goal would be to use what a player did as a baseline, right? So we're going to establish some weights based on what the player did, since you have your reward function and you kind of have like your structure. Hopefully, have all the data in there. And also, it's ordered. I forgot to mention that, but it's also ordered. So if you're doing some sort of like replay buffer or something like that, you can ingest these things in order, right? So you're not going to miss out on that. You can kind of emulate an actual like real time reinforcement learning setup, right? So it's all to get you started, to give you decent weights, and then your self-learning experiment can start with a better baseline, kind of like when you're transfer learning with ImageNet algorithms like VGG and Inception and so on and so forth, right? So that's the big hope, the big goal. Now I'm sure people will get creative. You can use this for other purposes, but the main goal is really like this, starting from a better place. Because we've done on my live stream on Twitch, I've done quite a bit of experiments with Serpent.AI and reinforcement learning stuff. And the big pain is always this random initialization in the beginning, because it could be so far from what it needs to do. And then the learning rates can only be so big that there's generally a lot of waiting, like just to overcome the randomness in the beginning. So anything that makes you wait a little less with machine learning stuff is always pretty amazing. So that's the feature. That's in essence the feature. I'm actually really proud of this feature, because it's pretty complicated stuff, and what you get in return is a single packed HDF5 file with all and probably more than you can use for your machine learning model. So I'm really proud that we brought this, that this was brought over in the latest release. Hopefully you'll find something awesome to use it with. If you have any questions, you can always hit me on the Serpent.AI Discord. You'll find the link in the description of the video. Thank you for watching this. Hopefully it was educational, and hopefully it'll get you interested in trying out the Serpent.AI framework. All right, so until next time, thank you.